Okay, bisectors of a triangle. There's two of these. And it has to do with yesterday's lessons, what we did. So remember I showed you if you bisect a segment, or if you make the perpendicular bisector, you got to just kind of estimate where the middle is, and then you draw a line that's 90 degrees through it. Show that it's perpendicular, and show that this equals that. Right? Yeah. To do an angle bisector, you just kind of got to draw a line that, as best you can, that cuts that in half. So, remember the whole idea of these two things is any point on a perpendicular bisector is equidistant from each side. And any point on the angle bisector is equidistant from each side of the angle at a 90 degree. Okay? So, today is really the same stuff, except it's in triangles. So, I'm going to do this over here so you can see, because you are going to have to draw these, like when we take a test and on some assignments.
Whoa, hey, we need to draw?
Yeah.
Nice.
Okay.
Hey.
So, of the triangles, there are three types of triangles, right? What are the three types?
Isosceles, scalene.
You're close. Close. Obtuse, acute, and 90, right.
Straight.
So, when we do the perpendicular bisectors,
I'm just kidding, I'm black.
No, not really.
Please stop talking about me.
Cat, you're so darn cute. We're not talking about you, we're just.
okay, you'd either have an acute, a right, or an obtuse.
Eat my
Eat some shut up.
So sweet.
Okay, so you are going to have to sketch these perpendicular bisectors in a triangle and angle bisectors in a triangle. So, when you do this, instead of doing one segment, there's how many segments? Three. So, you just estimate where the middle is, and you draw a line that makes a 90. Sometimes it'll go through that vertex, sometimes it won't. And then you got to show it's 90, and you got to show that it's bisected, right? There's one side. Now you got to do the other. Just kind of guess where the middle is. Draw a 90 through it. Show that it's 90, and show that that side equals that side. And then the third side, this is actually a construction we'll do on Friday, is when you draw the third one, all three lines will intersect at a certain point.
What's that point called?
It's called the point of concurrency. And it actually does have a name to it. Okay? So, if it's an acute triangle, that point of concurrency is on the inside. When you do this one, if I bisect that side, and then bisect this side, and then bisect this side,
Point is on the outside.
the point is not on the outside, it's on it. It's right on the midpoint of the hypotenuse. And then when you do an obtuse, it is on the outside. Oops, pretend those intersect. Okay? So the perpendicular bisectors will always intersect either inside, on, or outside. The angle bisectors, if we draw one, you just put 2 arcs there to show that that's bisected. 2. And really, when we do this in real life, we don't have to do the third because it is gonna, my line is really off. I gotta change that. We wouldn't really need the third because we already found that point there, but the third would intersect through them. A point inside the point of concurrency. So for this angle bisector, this one, and this one. Okay, so they're both inside. What do you think is going to happen on the obtuse? It's going to be inside too. This one's harder. This one's the.
It's okay.
Whoa.
You get it? Whoa, that's nice.
Okay. Now, those point of concurrencies have an actual application. When you find this point, if you remember on a perpendicular bisector, any point on the perpendicular bisector is equidistant from each of the endpoints, right? So, on this line right here, this point is the same distance from here to here, right? On this one here, this point is the same from here to here. And on this one, this point is the same from here to here. So what this shows us is this point is the same from all the vertices. That's going to equal that, it's going to equal that. Okay? Same thing here. The distance from here to here, there to there, and there to there are all the same. And here, from here to here, here to here, and here to here, they're all the same. So what this does is, if you took a compass, you know what a compass is?
Yeah.
One of these, and you opened it up from this point and put it up to one of them and went around, it would form a, yep, a circle around it.
360.
That's not a perfect circle, but. Okay, if you put it here to here, the circle would just touch these three and it would come up here somehow. This one, it would be just like this. Okay, so you can put a circle around an object by doing the perpendicular bisectors. That's called circumcenter, right? Okay, so this point is called the circumcenter. All right, because you can, if they say to circumnavigate the globe, that means go around the globe, right? Okay, so circumcenter means you can put a circle around it. The angle bisectors is different. On an angle bisector, if you've got an angle and you draw in the angle bisector, every point here is the same distance from each side. So, any point here is the same distance from this side and that side. Anything here is the same distance from these two sides, and anything here is the same distance from these two sides. So that means this point is the same distance from the sides, not the vertices, but from the sides. So from here to here, here to here, and there to there. Those are all the same. Same thing here, although my drawing isn't very good, but there to there, there to there, and there to there would be the same. And here to there, there to there, and there to there would be the same. Now, if you took a compass and opened it up from here to there and drew a picture, what would happen?
It'd be inside.
It'd be an inside,
In center.
in center. Are you looking at the board, Mason, or?
No, I'm just taking wild guesses.
Good job.
They're crazy, dude.
So you can draw a circle inside, which means that point is called the in center. Okay?
That works too.
Now, in this chapter, there's perpendicular bisectors, angle bisectors, altitudes, medians. I think it's just those four. They all have different names. And you do need to know the differences between those names. On an ACT test, I did see one where they asked what the orthocenter was. So you needed to know orthocenter is this, where the points meet on the altitudes, which we'll learn later. Okay, so you need to know what these points are called, and you need to know the difference between them. This one gives you the distance from each vertex. This one, the distance from each side are the same. So that's the difference between the two. And again, those are two of the constructions we got to do, is actually do those on Friday. Okay, so here's an example where there's 3 boats in the water. The boats are equidistant from a buoy. Everyone know what a buoy is? Floats in the water. So if we connected these boats, no, it just forms, it looks like it's an obtuse triangle. Now, these are the types of problems where you got to decide, do you got to do the perpendicular bisectors or the angle bisectors? They're all equidistant, the boats are from the buoy. So you'd have to do the, right. If it's the same distance from 3 points, it's the perpendicular. If it's the same distance from the actual sides, it's the angle bisectors. So what you would do then, and again you just do this on your assignments, is just sketch in. So just sketch in, form a 90, show that it's bisected. Choose another side. 90, show it's bisected. And you only need to do 2, because the third one is going to intersect there. We know that. So this is where the buoy would be. An example of a word problem where they'd have the angle bisectors is if they've got some streets. It's not really a great intersection, but say the streets come together like this. And this is a park, and they want to put a monument in this park, and they want it to be the same distance from every road. So it's not from the points, it's from the actual road. Then you would do the angle bisectors. You just sketch in one, sketch in another, and that's where the monument should be. Okay, so see the difference between the 2 types of problems? Yeah, it does get, especially when we throw in medians and altitudes. There's 4 of them that all have an application. The actual problems, though, I mean, you do need to remember what the properties are, but they're not so hard. Here, these are perpendicular bisectors meet at S, which means this equals that equals that. That's what you need to know when you see perpendicular bisectors. So, how long is PS? 10. Because if that's 10, they're all 10. And how long is QS? 10, they're all 10. Okay. Here, this is 9.6, so would that be, because they're cut in half. This is 8, so would that be. This is 9, so would that be. Okay, here we got an angle bisector one. On an angle bisector, the point is the same distance from every side. So, which segments are congruent? It would be MH, HM, HP. Find HN and HP. Now this one They don't really put this book in the correct order because we haven't done this yet. They're the same. But now if you look at this, this, and this, what does that form?
Oh, right triangle.
And we know this is 24, and we know this is 25. We're looking for that. So I don't know why they don't put this earlier in the book so we can learn it, but we've kind of done, I've shown you a couple of these before.
What do they add up to?
If you know in any right triangle, if you know two of the sides, you can find the third by using the Pythagorean theorem.
Oh, I hate that.
A and B are the legs that form the 90, C is the hypotenuse. So we're missing a leg there, so that's x squared. Plus the other leg is the one that forms the 90, that's 24 squared, equals the hypotenuse is the longest side, 25 squared.
Okay.
So in order to solve this, you got to subtract 24 squared. Now on your calculator, remember, don't go 25 minus 24 and get 1. You got to go 25 squared minus 24 squared. And you get 49 equals x squared. So if x squared is 49, what's x equal to? 7. Because remember, to get rid of a square, what do you got to do? Square root, and you get 7. So these lengths would all be 7 right there. Okay? The ones on the assignment, I'll show you which ones you got to use the Pythagorean theorem on. Okay, here we've got angle bisectors, which means this equals that equals that. So to figure out what D is, what do you know about this and that? They're equal. 2D plus 7 equals 4D minus 1. And in geometry, I haven't said this for a while, but when you write an equation, one of two things is going to happen. They're either going to equal each other or they're going to add up to equal something, usually 180. So, solve it, get the 2D out of there, so you subtract it to move it over here. Get the non-D over here, it's a minus, so you add 1. Drop the equal down, divide by 2, and you get 4.